In this video, we're going to be taking a look at activity 414, which is called modeling mechanical motion. And one of the things in the activity we'll have is we'll need to upload the various parts, the VexIQ parts, in order to create some of the assemblies of the different mechanisms that we've explored in activity 413. So the first one we're going to be taking a look at will be a pulley assembly. And what I'm going to do here is I need to make sure that I hit save. So I have a folder created, activity 414 mechanical motion. And within that folder where all the parts are, I usually try to keep them all together. I'm going to hit the save button and I'm going to call this pulley mechanism assembly. And I'll say save. What I'm going to do here is I need to bring in a 1x8 beam. So I'm going to right click on this and say insert into current design. What I can do here is you'll notice this brings up the move/copy tool. So I'm going to first off get this positioned correctly. We're going to rotate this 90 degrees and I'm going to say OK. And then I'm going to come over here to the browser and I'm going to right click and I'm going to choose ground. So before I forget, so that way this component doesn't get moved. I'm going to go ahead and also bring in a couple other components. We need a 2-inch shaft. I'm going to insert into current design and I'm going to go ahead and rotate this into place, and I'm also going to translate it. This roughly it's going to be in this second hole from the left side, so I'm going to go ahead and do that. Another option we can do, rather than inserting another one, we can say move copy. You can choose, I'm going to choose this end here that kind of aligns with the X, Y, and Z axes. I want to make sure from the box here, check create copy, and then I'm going to go ahead and just bring this over. So again, this one here is going to probably be, they don't really give us a location, but looks like to be about the second hole from the right end. And I'm going to say OK. From here, I'm going to find my pulleys. So I need one 10 millimeter pulley to bring in. You'll notice that you will want to go through these, will kind of get in the way. And I like to use the little grips to drag and to rotate these into the proper position that they're going to be in. And we need a 40 millimeter pulley. Again, click and drag and kind of get these into place, rotate them. The other thing too that you'll notice on this 45 degree pulley, or the 40 millimeter pulley, is we need to adjust this by 45 degrees, so then that way that this will go through and actually the square hole that is in the pulley will line up with our axle. So I'm going to go ahead and rotate that by a negative 45 degrees. And really, you can also rotate it around clockwise or counterclockwise, as long as that is lining up perfectly. All right, so with our pulley assembly, here's what we're going to end up doing. So we're going to set up a few different joints in order to make this happen. So I'm going to go ahead and click on joint. I'm going to go ahead and choose, I want to make sure my option is set to Revolute, so I can do that from here or from this menu as well. But when I do move to this tab, I do have to hit the select button to get my options. So I'm going to choose my shaft and I'm going to choose the end of it, and then I'm going to go over here and choose the circular edge on the hole, and that's going to line those up. Now I'm going to go ahead and apply an offset, which is automatically set up there, and I believe this should be looks like it's not exactly pulling up the correct offset we want, X. So let's put that back to 0. We want a Z offset of 1 inch. So it's not going to quite be 1 inch, but it's going to be close to what we're, as far as for the precision on this activity, it'll work out just fine. Okay, I'm going to go ahead and move this pulley out of the way. Now you will need to capture the position, so then that way it doesn't throw that little error message, or not really an error message, but a little dialogue up there. But here we go, motion, Revolute, choose the same thing here on this shaft, and choose the same thing on this one. Again, the offset Z, we're going to go for 1 inch, and we're going to say OK. So here's where our particular case is. So we get spinning motion in here, and after I change that, you'll notice it stays in that position. I'm going to go up here and select revert, so that way it lines those up, so that way I can put my pulleys on there accurately. So I'm going to go ahead and take a look at this pulley. I'm going to go ahead and choose the move option, and I can go ahead and move it a little closer, so that way I don't have to be so zoomed out. So I'm going to zoom in here, that way we can show you this process. I'm going to say joint, I'm going to capture the position if it prompts me to, and then I'm going to go ahead and choose the rigid constraint. And in order to select this, I'm going to kind of rotate this model around just a little bit here as I take a look. And looks like it's not very friendly with my joint tool being active. So let's go ahead and run it again. Capture the position. So when I run the rigid command, I'm going to change the type from the little pop-up menu. So you'll notice that pops up rigid, and then I'm going to hover over the flat face here, and you're going to notice I'm going to get some corners around the hole, and then there's also a center. But if I try to move toward the center, it goes to the inside. So what I have to do is I have to hold the control key on my keyboard, and that'll lock down. So now I can pick these points off of this face, and I'm going to choose the very center point, and it's going to throw the joint origin chip right there at the center. And then I'm going to choose the one right here as well, and it is going to flip it because of that. Now it's okay if it's flipped, but I'm going to go ahead and change the offset. So this is in the offset Z. I'm going to go ahead and do 0.75. Now it's going to kick it out toward us, so let's go ahead and we want it to go onto the shaft, so I'm going to do a negative 0.75. And then that way that goes through and sets it up. You can kind of tell from the top how far that's being threaded or kind of pushed onto that axle. And I'm going to say OK. Same thing here with this pulley. It's the same kind of scenario. I'm going to hover over this face, hold the control key, choose the center, and I'm going to do the exact same thing on this one here. It's going to flip it. My offset Z, negative 0.75. We want it to match up with the same pulley on the other side. So when we say OK, look from the top, you'll see both of these pulleys. If I drew a line from here to here, they would line up together. So what we're going to end up doing, now that we've got these assembled, is we are going to go through and take a look at doing something known as a motion link. So a motion link under the Assemble tab, I can choose Motion Link, and these joints, it's going to link them together. So I'm going to choose the Revolute joint on this axle, and I'm going to choose, or on the shaft, and I'm going to choose this on this shaft. And you're going to notice that there we have some spinning rotation, that when one moves, the other one is going to move at the same time, and then that way we're able to go through and get that. Now in this scenario, we end up needing to take a look at a few things. Many times in a pulley, if you had a belt running around this, we would end up going through and turning this. If we needed to reverse, we could reverse the direction. But however, with a belt, like in a case if you had a belt between these two pulleys, we would go through and just need to kind of maintain the same direction. Now the only thing is the amount of rotation that each one is going to do. Right now the way it's set is these guys are moving at the same amount of rotation, and that's really not representative of the real world. So what we end up looking at is that this pulley is a 10 millimeter diameter pulley. This is a 40, and when you look at a gear ratio or a kind of a ratio between these two, what you're seeing here is that this pulley is 4 times as large, and a larger pulley is going to spin slower. And there's a direct relationship with that ratio. So what that means is this is going to turn 4 times slower because it's got it's got a larger distance to carry. This one's going to turn 4 times faster because of that. Now there's also some relationships between speed, with speed and torque. So obviously, if you want higher speed, you want your output to be on the smaller pulley. If you want higher torque, then you would put this pulley as your output, and so on and so forth. So if our first pulley, Revolution 1, which is what we chose, which was our first one that we did, if it's moving 360 degrees, then what we need to do is we divide 360 divided by 4, and we're going to put that at 90. So now you're going to end up seeing that here is the look of it, 360 degrees. In comparison, it looks like it's flying around this the shaft is being turned and it's just flying through the revolutions, and this one is going slower, which is a little bit more accurate to the real world, kind of what we're seeing in this particular case. So that's going to be how we go through and we take a look at doing this pulley assembly. So check out the next video for where we'll look at the spur gear mechanism, and look at the